All right, welcome back to Calc 2 here. So we're going to go through some homework walkthroughs here and see what we've got. So this section, I think I'm going to do 4, 5, and 6. All right, so I'm going to jump around a little bit from the next ones because we're going to hold off on this normally distributed stuff, and I'll do those last. But this is just going to be 4, 5, and 6. All right. So what are we looking at here? So it says, okay, here is a function, right? C over 1 plus x squared. And it said, for what value of c is this a probability density function? All right. So they don't tell us any restrictions on x, right? They just let that go. So we're given f of x is equal to c over 1 plus x squared. And we're going to go ahead and assume that it's over all the reals. Okay, x can go from negative infinity to positive infinity. And as a matter of fact, this is actually this is a pretty famous distribution. Okay, this is called a Cauchy, C-A-U-C-H-Y distribution. And the reason it's interesting, and we'll get into that at the end here. Okay. So the first thing, right, figure out, okay, what value of c. So we have to integrate this. All right, we're going to go from negative infinity to positive infinity of c over 1 plus x squared dx. Okay. Now, right, again, we get all the joy of all the improper integrals here. I really care that you are good about following all the notation and improper integrals in this section that is. If you slide a little bit on this one, I'm not going to be happy, but I'm also going to understand. Okay, so we're going to take limit as b approaches negative infinity of the limit as a approaches positive infinity. Actually, I think, we could probably do a negative b to b kind of a thing. Okay, let's do that rather than have two limits sitting here. All right, and we're going to go from negative b to b, c over 1 plus x squared dx. Now, you could look at 1 over 1 plus x squared and say, that is inverse tangent. Okay? If not, I guess we can go through and do a triangle, but I know how much fun that is. So we have c times the inverse tangent of x as we're going from negative b to b. And I'm going to let that limit stand for the whole line here. So we are going to be looking at c times the limit, right, as b goes to infinity, of tangent inverse of b minus tangent inverse of negative b. All right. Well, what is the inverse tangent as x goes off, or b goes off to infinity? Right? Do you remember what inverse tangent looks like? That function, an asymptote here at pi over 2. Down here, there's an asymptote at negative pi over 2. So inverse tangent as x goes off to infinity is going to be pi over 2. And minus, and then look at this, we've got a negative pi over 2 down here. So pi minus a negative pi over 2 minus a negative pi over 2. That's right. That's pi, isn't it? Okay. So, and do you remember what this whole function has to integrate out to? This whole function has to integrate out to 1, doesn't it? So this is equal to 1. All right, and then we get c is equal to 1 over pi. Okay, that's your Cauchy distribution. Okay, so we have f of x is equal to 1 over pi, 1 over 1 plus x squared. That'll make this thing integrate out to 1. Right? That's exactly what we want here. All right, next thing, they want to know what's the value between negative 3 and positive 3. So at that point, right, we do negative 3 to positive 3. We don't have to deal with a limit, right? This is 1 over pi, 1 over 1 plus x squared dx. Knowing that this thing is also, right, this is inverse tangent. So this is 1 over pi we have tangent inverse of x minus, oh, no minuses, evaluated, right, from 3 to negative 3. Right? So here we have 1 over pi. We have inverse tangent of 3 minus the inverse tangent of negative 3. All right. So let's see here. We have inverse, where are we? Second function tangent of 3. We have 1 over pi. And what does it tell us to do? It says report to 3 decimal places, so that's what we'll do. All right. Otherwise, this is the answer. If they don't want any decimal places, they want exact. We're done at this point. All right. Actually, we can do a little bit more. I'll let you say, oh yeah, that's right, when I get there. Okay, so this is 1.24, 1.250. All right, 1.250. Okay, minus, and then we have to do inverse tangent of negative 3. So here's second function tangent of negative 3. Oh no, look at that, negative 1.250. Tangent, inverse tangent is an odd function. So f of x, right, equals negative, or yeah, we have that thing. So if I know that f of x is 1.25, I know that f of negative 3 is going to be negative 1.25. Okay, so that was that. I'd say I tricked you, but I know I didn't. All right. So 1.25 and 1.25, that's going to be what, 250 divided by pi. So we have 2.50 over pi, and that is approximately equal to 2.5 divided by pi. Right, we got 0.795. All right, I'm used to probabilities being 4 decimal places. Okay. And almost every other, well, not every other book, but all the probability books, all the intro to stats books, they're 4 decimals. Okay, and that's because way back in the day, right, when we have to do normal distributions, and we made tables for them, and they were in what they call CRC books. I don't even remember what this stands for, but we'd have to look these things up in a CRC book, and they always went out to 4 decimal places. So everything is 4 decimal places, like sines, 4 decimal places, square roots, 4 decimal places. All right, probabilities, 4 decimal places. All right, so point, right, 796, 796. I'm going to ask you to do one more thing. I'm going to say, what's the expected value of this function, right? What's the expected value? So what we're going to do here, right, we're going to integrate from negative infinity to positive infinity again. And we're going to go, right, this is 1 over pi plus 1. We're just going to move the pi up a minute times x. Negative infinity to positive infinity, and that's x over x squared plus 1. And we have a 1 over pi. Okay, just moving things around to make things a little bit easier to look at. It's not a bad integral, right? There's an obvious u substitution here. So we're going to find the limit of a, of negative a to positive a. All right. We're going to integrate back. Okay, we're going to go back to x is here. So we're going to say let u equal x squared plus 1. Du is equal to 2x. Excuse me. So I need a 2 in here, right? I need a 2x. But if I'm going to do that, I need a 1/2. That way it keeps it even. And then we have our pi. Okay, and then we have our x squared plus 1 x, and now we can substitute, right? Dx. So we have 1 over 2 pi integral. All right, and we have negative a to a. We have our limit as a goes to infinity of our 1 over u, because that was x squared plus 1, du. So far, so good, right? Looks pretty good. So this is 1 over 2 pi. This is the natural log of u. Okay, from negative a to a. Again, I'm going to let that limit stand for the whole line. I really shouldn't write down the a's here because they're, we should be dealing with limits for u, but we're going to turn back. Okay, so we have 1 over 2 pi natural log of x squared plus 1. We don't really need the absolute values anymore because x squared plus 1 is always a positive number. All right, and there we go. So if I plug in, if I plug in this, I have pi. We have the natural log of a squared plus 1 limit as a goes to infinity minus the limit of a squared plus 1, because we have that. But what do you know about taking an infinite minus an infinite? It ain't 0, right? You learn that from L'Hopital's. It ain't 0. So this diverges, and then we're done. Okay, so the Cauchy distribution has no mean. Okay, which means it also has no standard deviation, no skew. What's the next one up? No kurtosis. That's not bad breath. It has to do with like how spread out things are, how fast the distribution hits the line here, the axis, or gets close to the axis. But everything you would want to know about distributions, mean, standard deviation, skew, etc., doesn't have one. Okay, doesn't have one because we have infinity minus infinity here, and that ain't going to go. So yeah, diverges. That's why it's an interesting distribution, is because it looks really tame, but it doesn't obey. It doesn't have any more rules after this. Okay, what it looks like, it's real. Again, yeah, it looks like it should have everything. The whole distribution kind of looks like that. Like, yeah, but this one doesn't. Shoot. Okay, so that's an interesting thought, right? Let's see here. Number 5. Number 5 is going to be a bit of a pain. It's a nice distribution, right? Again, this one looks real tame, but it's going to be a bit tedious trying to do this with calculus. Okay, so there we are with that. Explain why it's a probability distribution function. Well, the total area of the curve is 1, and it's always positive. That's it. None of the rest of this stuff matters. Okay, its total area is 1. How do I know that? We're going to test that. Well, we're not going to test it. We're going to take the word for it. Okay, following distribution. Like, how do I know it is? It is. All right, they're not trying to trick us that way. If they wanted to trick us, they would say find a C so that this shape was a probability distribution, and they make us do it. All right. So the first one, right? Or not the first one, but the second one. Right, says find the probabilities. Find the probability x is less than 3. All right, an easy one. Okay. This is called a triangular distribution. But you could figure out why. The area, right, from 0 to 3 here is a triangle. So we could just figure out 1/2 base times height. Right? Why do the calculus when you don't have to? So this is 1/2 times 3 because the base is up to 3, and then the height is 0.1. Okay, or 1/10. So this is 1 over 2 times 1 over 10 times 3. Okay. 3/20, 0.15. Okay. 1/20 is a nickel, so 3 of them is going to be 15 cents. All right, Gesundheit. So the next one, I was so disappointed. When I did this one earlier, like to kind of prep for this, it stopped at 6. I was like, oh, thank goodness. This one stops at 8. Oh, no. Okay. It didn't really matter because we had to calculate the mean, so we had to do a lot of work anyway. But going from, 3 to 8, so I've got to go from here to there. Okay, we could kind of figure out this triangle. Actually, that's not a bad way to go, right? We have this triangle, We have this triangle. Okay, so let's instead of just one that, right? We have this, and then we have that. All right, and here's 8. All right, and this is 6, 5, 4, 3. So what we want, okay, we want this area here. All right, so use all of your area tools that you learned so well in the 5th grade. Okay, that's what we're doing. Or you could use calculus. Okay, either way. Since I know what part C is going to bring, we can go ahead and just figure out the area this way. But quite honestly, like, nah, why don't we do it this way? Why don't we take this triangle minus that triangle, and that'll give us what's here, right? So this is big triangle is 1/2 base, which is going to be 6 times its height. I have no idea what its height is. It looks like 0.2. Okay, times 0.2, right? Minus what we just found, right? Because we just want to figure, we want to get rid of, right? We want to subtract off that. So we're going to subtract off 3/20 here. Okay. So what do we have here? We have 1/2 times 1/5, right? 0.2 is 1/5. That'll be important later. Okay. So that's going to cancel. That's going to be 3, right? So we have 3/5 minus 3/20. That's going to be a 4 and a 4. That's going to be 12/20 minus 3/20, and we are left with 9/20 on this part. So this bit in here, this is 9/20. Right? Now we have to figure out that bit. Okay, so the whole right hand side of this triangle, right? 6 from 10, that's a base of 4. So we have 1/2 times 4. What's the height here? The height is again 0.2. It's a 5th. Right? So that's going to be that's going to cancel. We have 2 here. So we have 2/5. Okay. That's for this whole triangle, right? That's, let me use a different color. Let's do purple. So that's this triangle here is 2/5. Now we're going to subtract off this little guy here. All right. So from 8 to 10, that base is 2. And what's my height here? It's 0.1. Right? So that's going to be, those are going to cancel. We just end up with 1/10. So we have 2/5 minus 1/10, or 4/10 minus 1/10, which is 3/10. So this bit in here, that's 3/10. Just got to add them, right? We have 9/20 plus 3/10. So 9/20 plus 6/20, 15/20, and I think we can cast out a 5 here. So that's going to be, right, this is 5 times 3, so 3. This is 5 times 4, 3/4. Okay, beautiful. All right, that was just a lot more work than my little example problem minutes do. Okay, next. Now we get the really fun one. Calculate the mean. Oh no. All right, so the average, right, let's go back to blue for a minute here. The average, right, is x times f of x. All right, easier said than done. We've got to get what the heck is going on with this triangle. So f of x is equal to, right, now, thankfully, this first half is going to be real easy, right? It's a slope, it's a line that goes through the origin, so there is no, the b is 0, and all we need is a slope here, okay? So we have, right, the rise, 0.1, over the run, right? This is 3, right? So 0.1 over 3x. All right, so that's 1 over 30x, and that's when x is between 0 and 6. Okay, now get this equation. All right, so again, right, rise over run. So let's see here. We have 2 points. We have 6 and 0.2. So we have 6 and 0.2 as 1 point. And we have 10 and 0, right? 10 and 0 is my other point. So let's figure that out. So the change in, right, the change in y, that's going to be 0.2 minus 0 over the change in x. That's going to be 6 minus 10. So we have 0.2 over 4, or 1/5 times 1/4, which is 1/20th, right? Oh, that's -2, right? So our slope here is -1/20th. So m is equal to -1 over 20. Now, right, you remember point slope form, right? Pick your favorite point. I'm going to pick the one with 0 in it. So we have y minus 0 equals -1/20th, x minus 10. So here we have it. We have -1/20th, x, negative times a negative is a positive, times +1, or plus +1/2. So here we have -1 over 30x. Here we have -1 over 20x plus 1/2 between x and, or 6 and 10. Okay. See how much fun this could be? Now we're going to take x times this. Okay, we're going to take x times that. Oh, I forgot to set my clock. I was going to time this to make sure I wouldn't go too far. Right. So what we're going to have is we need the integral, right? And this is the integral over all of it. So we actually have the integral of 0 to 6 of 1 over 30x, right? And then plus, we have integral from 6 to 10 of -1 over 20x plus 1/2. And what are we supposed to do when we find an average? So we multiply this by x. There's a dx here. Dx here. Okay. So, you know, the calculus is not going to be that bad, right? This is x squared over 30 plus -120x squared plus 1/2x going from 6 to 10. Delightful. Okay, and now we just have to plug this through. So this is going to be x cubed, right, over 3. 3 times 30 is 90. Plus, we have -1 over 60, 3 times 20. That's going to be x cubed. And then we have, right, and this is, right, this is going from 0 to 6. This is going from 6 to 10, right? And then we have 1/4 x squared. Okay, and then we get to evaluate all of this stuff. Okay, so that's one set of problems. This is another set of problems. Okay, so fortunately it's 0, that's 0. So we just get 6 cubed, which is 216, right? If you guys play Dungeons and Dragons, any self-respecting D&D player knows that 6 cubed is 36, because that's what you divide by to get your probabilities. Okay, and then we have -1000, right, over 60. We're evaluating the x equals 10 here, plus 1/4 times 100, okay, minus, and then we have to evaluate at 6, right? This is evaluated at 6. So we have this little piece, minus, negative, again, 6 cubed, 216 over 60, okay, plus 1/4, and then 6 squared, 36. I'm sure this will all work out perfectly. I don't know, it's really weird. My high school math teacher, he's like, any good mathematician should know that 2 to the 5th is equal to 32. I've never forgotten that stupid fact. So hopefully you know, you guys will be going off and thinking to yourself, I'm a self-respecting D&D player. I can know three cubes or 6 cubes rather is 216. All right, I am gonna punt. Okay, that's all I'm doing here is I'm just punting. So I'm not even going to make an effort because there's way too many simplifications. I'm going to screw up way too much arithmetic here. Okay, so this is minus, actually I could do a little bit. Right, 1,000 over 6, 100 over 6. Over 6, plus I know 100 over 4 is 25. Okay, we could do that. Okay, let's see here. I'm not even gonna worry about it. Plus 216 over 60. I peaked, by the way. The answer should be 5 1/3. And then minus 9. All right, fingers crossed. Look at that, it's 5 1/3. Okay, so that's my average. You all would have expected that just by looking at the picture, right? Going back up and looking at the picture, you would have said, obviously, it's 5 1/3. Right? Sure. I am not interested in trying, you know, if I ask you guys one like this on the exam, I didn't. But if I had, I'm looking for the setup. I'm looking for, did you know what to do with the numbers? I am not looking at your arithmetic. I could care less. All right. Given another chance, we would get a different answer. Even trust me, I would get a different answer. All right. Let's see. Let's do one more. All right. Let's see if I have it. Number 6. All right. Let's take a look at number 6 here. That's 5. Number 6. Find the median waiting time for a phone call to the company described in the example. It's the example at the top of the page, by the way. Round your answer to 2 decimal places. All right. So they're going to hand us this. All right. This is the function we have. F of t is equal to 0.2 e to the negative t over 5. Okay, so we have equals 0.2 e to the negative t over 5 when t is greater than or equal to 0 and 0 otherwise. You remember that 0.2 is really a fifth. So it's 1/5 e to the negative t over 5. Okay. And they want to know the median. Oh, joy. All right. So when we're integrating, I think we asked you to pretty much integrate everything and solve for everything you possibly could, except one of the limits. So congratulations. We're gonna do one of the limits now. Okay. So this is how you set up a median. This integral, 1 over 5 e to the negative t over 5, this has to be equal to 1/2. That's how we're going to figure out m. This whole thing has to be equal to 1/2. That's what median is. Okay. I always thought these problems were really cool when I was doing them. I can appreciate that not everybody would think that. All right. So, yeah. Okay. We have an improper integral, joy. So limit as a goes to infinity of m to a. Okay. And we have a 1/5 e to the negative t over 5. All right. I'm going to go back to the t world, but for the moment, I'm going to go put everything in the u world because maybe it's been a while. So u is equal to negative 1/5 t. du would be negative 1/5 dt. If only I had a 1/5 somewhere with a dt. Okay. So limit a approaches infinity. We have an m. We technically have a u sub m and a u sub a. Okay. Because we're changing what's going on here. I have a negative. Here's my negative. Right? We need a negative here. We need a negative there. Negative 1/5 dt. That's going to be du. And then we have e to the u. Oh, an integral worthy of a homework problem if I ever saw one. Okay, so this is just e to the u, negative, right? And of course we have our limit. Okay, we're still in the u world, so these aren't really the limits, but let's go ahead and map it back. So we have negative e to the negative 1/5 t. Now we're back in the t world. We have m a limit equals 1/2. Okay, let's write that down a little bit nicer. So we have limit as a goes to infinity. Okay. Let's see. We have negative e to the negative 1/5a. Okay, we'll put that negative here. Minus e to the negative 1/5 m, excuse me. All right, and there we go. And this was equal to, right? As a goes off to infinity, what's going on? That's 0. So that's negative 0 minus e to the negative m/5, right? Equals 1/2. Negative times negative, we get e to the negative m/5 is equal to 1/2. And now we got to solve for m. Do you remember what to do when you have a variable in the exponent position? Hopefully me just asking that question will jog your memory to say, oh yeah, natural log. Right? This comes down in front, so negative m/5 times the natural log of e. Do you remember what the natural log of e is? 1. Right? I'm going to do this too. I'm going to say this is equal to the natural log of 2 to the negative 1, because that's what 1/2 is. So this is negative natural log of 2, and that's equal to negative, wait a minute. Did I forget a negative? No, I'm okay. I'm okay. Negative 1/5m. Multiply both sides by negative 5. M is equal to negative 5 times negative natural log 2, 5 ln 2. That's my median value. Oh, 2 to the 5th is 32. We could do that too. So that's when, I don't know what the complex context is. I think when the time hits 5 natural log 2, okay, or natural log of 32, then half, right? That's a probability that half would have happened by then. Okay. So that's how you find a median. Okay. Again, I thought this kind of problem was really cool when I was looking at it, but when I was doing this. But I've been since told by all of my former colleagues and most of my students that I've ever subjected this to that you guys do not find this to be a fun problem. Okay. So I picked a different one for your test, but for your homework, this is how you do it. All right. So I'm going to be back with the remainder. Well, not the remainder, but with another set in just a minute. And until then, we'll work on this. All right. Take care. Oops, I want to stay stop.